Okay. I guess now people have got some of my answers. Our curve is x minus 3 squared out of x minus 1, x minus 9. The first things are intercept. Someone give me the intercepts.
I have 3, 0. That is
You have what?
x-intercept.
3.
For the x-intercept.
Okay.
3, 0.
Y-intercept?
0, 0, 1.
0, 1. Do we all have that? Did people get turning points? Oh, did you? The question was saying, determine the range of values where the y does not exist. Did we get that part? There is only one person who asked me a question on that concept. I think that person was doing numbers. He's the only person who talks to me. Yeah, guys, have you got the region where the y values don't exist? How about the turning points? I'm only going to go through that part because it gives us the turning points, their nature, and the region where the y values don't exist. So it's the only part I'm proving. Then I'll expect you to give me asymptotes. Give me asymptotes. Vertical asymptotes are?
1 and 9.
1 and 9.
X is equal to 1 and x is equal to 9. You write them as equations. Don't just say 1 and 9. Yeah? Horizontal asymptotes?
Y is equal to 1.
Horizontal asymptotes, y is equal to 1. Very good. Y is 1. What method did you use for the horizontal? Cross multiplication, or you used the thingy? You used the limits. The lady was giving me the answer. Did you use cross multiplication or you used the limits?
Cross multiplication.
Okay, if you have used the cross multiplication, you should be able to give us the turning points. Can you? And the region where the curve does not pass. Okay, it seems you can't. Okay, well, when you cross multiplied, what did you get? You see you have y into x squared minus 10x plus 9 is equal to x squared minus 6x plus 9. Y minus 1 of x squared plus 6x, okay, plus 6 minus 10y of x plus 9y minus 9 is 0. The coefficient on x squared is the horizontal asymptote, which is correct. So y minus 1 is equal to 0 gives us the horizontal asymptote. Those of us who don't know how to get it. All right. Now we need to find the region where the curve does not exist. We shall have b squared is less than 4sc for no real roots. So we shall have 6 minus 10y is less than 4 into y minus 1 into 9 into y minus 1. So 36 minus 120y plus 100y squared is less than 36 of y squared minus 2y plus 1. The 36 and the 1 will vanish. So we shall have 100y squared minus 36y squared minus 120y plus 72y is less than 0. So we shall have, this one will confuse you as if it had left. Okay. So finally we get 64y, okay, y squared minus 72 minus 120. 120, there is a balance of 28. 28 plus 120 is 48. So 48y less than 0, giving me 8y into 8y minus 6 is less than 0. So that region is y is 0, critical points, and y is equal to 3 out of 4. So investigate y less than 0, 0 less than y less than 3 out of 4, y beyond 3 out of 4. When you check them out, you will have 8y, you will have 8y minus 6, sign of the function in terms of y. Hey, I've not treated it very well. So less than 0, it's a negative, negative, positive. Between 0 and 3 over 4, 3 over 4 is 0.75. I can take a half, positive, a half, negative, I get a negative. Beyond, I get a positivity, positivity, positivity.
Excuse me, teacher.
Yes, please.
Which part are you answering? Is it part 2? I'm confused. Part 2 or part 3?
Ideally, you were supposed to give me all the answers, but people are not giving me answers. So, I knew very well that if I use this method of cross multiplication, it can give me 1, horizontal asymptote. 2, it can give me the turning points. 3, it can give me the region where the curve does not pass in y. 4, it can give me the nature of the turning points.
So what about
the answer
the
in the first part? I'm answering the first part, though the second part has already been answered here. Okay? Now, because the inequality here was saying less than 0 is a negative. So y does not exist between 0, less than y, less than 3 over 4. And I told you, if it doesn't exist there, it means if this is where the 3 over 4 is, and this is where the 0 is, then this part is shaded vigorously, whereby when the curve comes, it will turn minimally on the upper boundary. Then when it comes from down, it will turn what? Maximally. There you would have got the nature of the curve. So what does it mean? Get 0 for y and substitute it and substitute here. Y is x minus 3 squared over x minus 1, x minus 9. Substitute, put 0 for y. When this is equal to 0, x is equal to 3. So when x is 3 is a turning point. So 3, 0 is an intercept. It is a 3 common item. It is an intercept, it is a turning point, and more so, it is turning how? Minimally. No, turning maximally. Because of this boundary. I've told you when it comes from down and meets the lower boundary, it turns maximally. When it meets the upper boundary, it turns minimally and goes back up. Now, substitute 3 over 4. 3 over 4, substitute it here in this bracket, in this relationship, because it is about expansion, or substitute it here for easy computing. So you will have what? 3 over 4 minus 1. You get a negative a quarter. X squared plus 6 minus 15 over 2 plus 9 minus 9y minus 9, you get 27 over 4 minus 9. Then you have got a quadratic in x. So you get a negative a quarter, x squared. This is 12 minus 15, you get a negative 3 out of 2 of x. Then 36 minus 27, you get a minus 9 out of 4 is 0. So the equation here becomes a negative x squared minus 6x minus 9 is 0. You see that the whole of this is x plus 3 squared is 0. So it is at x is equal to negative 3. So the next turning point is at negative 3 over 4. And here it turns how? Minimally. And it gives you 1 point, of course. Yeah. So when you get these boundary points, these ones of y, substitute them here in the equation, but don't substitute like an amateur. You have already expanded this way. So use these expansions and then find the corresponding x what? Values. So with that, we have the horizontal asymptote. We have got it is here. We have got the region where the curve does not pass. It is here, confirming this. We have got the turning points. It is this one and that one. We have got their nature, that one and that one. That is the best alternative out of cross multiplication. The cross multiplication can give you 5 items, other than working out each individually. Someone has a chart. Can't we use the differentiation method? We can. Sereko Ukasha. Sereko. Ukasha, either? Have you used
Yes,
differentiation?
teacher. No.
We can use
Yes.
differentiation, Ukasha.
Okay, sir.
But now I said, if the question is stated like this one, find the range of values where y values do not exist. Make sure you use cross multiplication because it will give you 1, the horizontal asymptote. 2, the region where the curve does not pass. 3, turning points. 4, their nature. Are you getting my point? But when
Yes,
you use
yes, teacher.
differentiation, you will differentiate, get the turning points. After differentiating them, you will investigate their nature. Yeah?
Okay, sir.
Let me using. I actually have not done an example using differentiation, have I? With turning points. Let me use this one. That what if I go for Ukasha's method? It would be x minus 6x plus 9 or is over x squared minus 10x plus 9. So the y, the x is going to be for turning points or for stationary points. The y dx has to be 0. So 0 would be equal to 2x minus 6 into x squared minus 10x plus 9 minus 2x minus 10 of x squared minus 6x plus 9. I had not done such a number. The others never had turning points, the first numbers I did. When you cross multiply, I told you even if you don't write the denominator here, because it cross multiplies to 0. So simplify the numerator, you will get 2x to the cube minus 20x to the square plus 18x minus 6x to the square minus 60x minus
plus 60x
plus 60x, minus 54, minus, open brackets, 2x to the cube, minus 12x to the square, plus 18x minus 10x to the square, minus plus 60x minus 90, close bracket. Everything is equal to 0. Now, Ukash, I think you can appreciate why the other method is better. This one is also okay. If the curve is not a very big function.
Oh,
Teacher, I haven't understood that alternative method. To Shime, which one are you calling the alternative? Vamoosh. This one and this one, negative 26. This way you have negative 22. It crosses over, you get a negative 4x squared. 18 and 60, you get 78. 18 and 60, you get 78. Vamoosh. Lastly, we have a negative 54. We have a negative 90. 90 minus 54, the answer is 36, isn't it? I think the answer is 36. So plus 36 is equal to 0. So x squared is equal to 9. X is equal to, wait, am I getting two values? X is plus or minus 3. This brings a very good thing. We shall do another number on cross multiplication. Don't worry. We are still solving numbers this week, next week. We are still doing curve sketching. So don't worry. Guys, did you get two possible values? Did you get two values, x1 and negative and positive? Because I'm getting negative and positive. But what I want to show you out of this is how to get, now I've got the turning points. If x is 3, so we have x is 3 and x is negative 3. When you substitute back here in the equation of the curve, when you put here x is 3 up, you get y is 0. When you put x is negative 3, you get a negative 6 squared, which is 36. Then down here, you'll get a negative 2. We shall see. But how will come this one? I never got the answers.
The other one, we shall have 3 out of 4.
How come here you have one answer? Maybe you have a problem. We're going to check this equation again.
So, but when you substitute the negative 3, you will get the 3 out of 4, which is
you get the 3 out of 4, which you have already.
Yes.
Okay. Yes. No, it is okay. I've understood. There are two turning points. Sorry. There are two turning points. One is here, one is there, not so. I was showing you the other method so that I show you how we get there. One which is minimum and maximum, using the old skill of all senior 5. Now, we have seen one is negative 3. We are going to test the nature. Left, right. Sine of divide what? Here it is a constant, here it is a constant. Now look here, guys. Do you see this last simplification here? Before you solve for the quadratic, it is what you investigate, because the downer part, I had forgotten, it was a square using quotient rule. So whatever it is in the bottom, whether you substitute there what negatives, it will always be a positive. Now the upper part is what determines the sign of the differential, because this is sign of dy dx. So if this was still dy dx, I had not yet put it to 0, I would still come here and say this is still dy what? Dx out of the other denominator, this one. Like that. So the numerator, this one, is the one which determines the what? The sign. So I was giving an explanation or the reason as to why I am investigating only the negative 4x squared plus 36. Now, before negative 3, pick any value. negative 2. When I pick negative 2 and I substitute it, we are substituting in x squared, negative 4x squared plus 36. If I substitute this one, this is our determinant for the sign of dy dx. When I put here negative 2, I'll get a negative 16 plus 36, which is a positive. A positive has a slope which is up in that form.
So we are going to the left.
Yeah?
Negative 4. On the
When you put negative,
on the
less
left
than
of
negative 3, sorry, yes, negative 4, you're right. Negative 4 gives us a 16. Eh? 16 times 4, you get negative 64. Negative 64 minus plus 36, you get a negativity. So a negative gradient faces this way. Okay? Then negative 2 will give us a what? A positive gradient, which has gone up. Because negative 2 is beyond, is on the right of negative 3. Now, come to positive 3, pick 0. When you pick 0, you get a positive. When you go beyond 3, you pick 4. 4 will give you a negative. So, remember our turning points were what and what? We have 3, 0. We have negative 3 and 3 over 4, I guess. Not so. Do you see that our 3, 0 is maximum? Then this one is what? Minimum, which is the same scenario we arrived at here. But I think, Ukasha, you have seen how long this method is, how tiresome the second method is for finding it. And this one, it is very obvious for all of us, we know it very well, but it is a little bit tiresome than the other one. Eh? Okay? So you see, you have to investigate the nature, you have to, but the other one, as long as you've got the region where y does not pass, this region was 0, 3 over 4. The moment you see that, and you've shaded this part, even if you have not calculated, and you arrive on the graph, and you sketch, and you show us that the curve came from up and it turned the minimum. It came from down and turned the maximum when it reached the boundary. All the marks are given to you there. Marks of the nature, marks of the turning point, marks of the region where the curve doesn't pass, though we don't know where you're getting them from. But when you show it on the sketch, it means you're using some points which you know that they are bringing out the region where the curve does not pass. And when the curve reaches that wall, it turns maximum. When the curve reaches that wall, it turns minimum. It means you know how the curve is moving. If I can proceed, any more questions? Teacher, what do you do if the curve has no turning points using differentiation method? Very lovely question, Elizabeth. Now, Elizabeth, according to your question, now, if the curve was like this one, and the equation was full, you investigate, is b squared greater than 4ac? According to this one, the b squared is not there. It is a 0x plus 36, not so? So you would say 0, is it greater than 4 times? No. Eh? Oh no, I'm just assuming. Okay, let me assume it is a 9 here. Is 9 squared greater than 4 times 36 times what? Actually, no, even this one was okay. If this is 0, Elizabeth, I'm trying to answer your question. She's asking me, how do I predict that the curve has no turning points using this method? You can try and say, the middle term is 0. Is 0 greater than 4 times negative 4 times 36? Yes. If 0 is greater or equal to 4ac, it means the curve has turning what? Points. But if it never had the turning points, it would have been like this one. Elizabeth, what are the values of x we get here? You said we get a negative 9. Eh? When you get a -9, you'll get I, 3I plus or minus. You get complex roots. When you get complex roots, it is evidence because we are sketching the graph on a real plane, not on a complex plane or an Gantt diagram. Hence, we conclude that it has no turning points. Whenever you see that last quadratic, this one, gives you a complex root. Was someone saying something? Elizabeth, I'm saying if you see that quadratic equation you have designed gives you a complex root, or its b squared is less than 4ac, then this will tell you it has no turning what? It has no turning points. Ali ku kyoyo. Okay, guys, did someone investigate where the region, other regions where the curve does not pass? In X? The other last part of critical points, X is equal to 3, X is equal to 1, X is equal to 9. Did you investigate? Or you did not? We have X less than 1, 1 less than X less than 3, 3 less than X less than 9, X beyond 9. We have X minus 3, it is already squared, everything is positive. A study student should be able to see that. X minus 1, X minus 9, sign of function in terms of when X is less than 1, 0, negative, negative, positive. Between 1 and 2 and 3, 2, positive, negative, negative. Between 3 and 9, 6, positive, negative. Eh? Very good question. Between 3 and 9, it is positive and negative. We still have negative. Beyond 9, positive, positive, positive. Now, whoever crams that they alternate plus, minus, you are finished on such a number. That is why I was asking, did someone investigate what signs have you got? But none of you has answered me. So I've gone ahead and finalized everything. Now, remember I told you if it is like this, it means you are still in the same what? Same region. So don't worry. Always investigate. Don't cram. That if I get the first one positive, the next one negative, positive, negative. Hello? No way. Okay, we are ready to sketch. Let me sketch this number. I've answered so many people's questions. Then we have one more other interesting suicide number of this kind. Then next week, we shall introduce improper fractions or improper or oblique curves. But today we are finalizing these normal curves. Okay, so that is our first graph. We have X is 0. Oh, let me shift this one. If we have X is 0, okay, I've overtaken it this way. Because I'm seeing everything is positive. Because everything is positive, I'm shifting my curve so that I have a small area on the negative side of the x-axis. So that's what we have to think about as steady mathematicians. So the first one is between 0 and 1, okay. That is between 0 and 1. Between 1 and 3. Okay, let me have it here. Between 3 and 9, yes, let me have it here. Beyond 3, beyond 9, sorry. We have a horizontal asymptote, but before I go for the horizontal asymptote, this is the y-axis. This is the x-axis. This is 0. This is 1. This is 3. This is 9. Oh, no, this one is not necessary. Yeah. Okay, with that, we had a horizontal asymptote. What is our horizontal asymptote? The horizontal asymptote is y is 1. Eh? So y is 1, where are you? You are here. But there is y is equal to 3 over 4, which predicts a what? The region where the curve does not exist. So our curve does not exist here. And even between what? And between 0. So I can shade this vigorously. Let me even use different colors. This shows the curve can never think of crossing this boundary. So I shade it vigorously, so that you clearly see that, my friend, when the curve reaches there, it has to turn. Then we had a horizontal asymptote, which we have seen. Our horizontal asymptote is here. Let me sketch it for you. Remember, you have to indicate that this is the horizontal asymptote. Y is equal to 1. Where the x asymptotes, x is equal to 1. You label them like that. And x is equal to, I think x is equal to 9 is a vertical asymptote. This one is not a vertical asymptote. Okay. Are we ready to sketch now? I think we are ready to sketch. So to sketch, before I can sketch, the curve is passing in the positive before positive 1. If the curve is passing in the positive before positive 1, where is the positive? Up. I shade where? Where should I shade before 1? Guys, before 1, where should I shade? Aisha Abdal. We are saying here where we have 1, the curve is positive. So where do I shade?
Down.
Down. So before 1 is the whole of this one. Okay. Aisha, between 1 and 3, the curve is negative. Where do I shade?
Up.
Between 3 and 9, the curve is still negative. Where do I shade?
Up.
You shade up. Thank you. Then beyond 9, the curve is positive. We shade?
Down.
Lovely. So here we go. We sketch our curve. So the curve turns at 3, 0 here. How does it turn? Maximally. So maximum turning of the curve is like this. Then it comes and meets this asymptote and it goes to infinity. When it goes to infinity, it comes back through the same asymptote, but on the other hand. So it has come back from this way. You see that? Then when it comes, it goes, it turns, because this is an asymptote. The curve never passes the asymptote, but it turns and makes a rectangular hyperbola, and it follows the asymptote parallel up to infinity. But this side, it goes to negative infinity. So it goes to my left, and it comes back through my right on the same asymptote, but on the other side. So it comes back.
Excuse me, teacher.
Yes, please.
Teacher, repeat how this. They come and go.
I think next week I will use my whiteboard to also demonstrate that. Because the whiteboard, which is traditional, this one is a little bit advanced. Okay, what happens is,
Excuse me.
Can you see my pointer? You see my pointer? I'm shaking it, right?
Yes.
Now, I'm assuming the curve has turned here maximum at 3. Do you agree?
Yes.
When it turns maximum at 3, it goes down. Because it is meeting an asymptote, x is equal to 9. Okay? It cannot cross through an asymptote to go this side because this side is shaded. It can't go there. Any shaded part, the curve cannot go there. It is a wall. It can't cross through. So what happens? It goes down as it approaches the asymptote. It becomes parallel to the asymptote. And it goes, if you're looking at the screen, the way I'm looking at mine is vertical. So assuming it is going down in the ground, okay? Following that asymptote, right? But the asymptote which takes the curve is the same asymptote which brings it back. But it can't bring it back through this same side because this side is shaded, you remember? So it will bring it back through this side which is unshaded. That is why I'm saying it brings it back through the opposite side. Okay?
Okay.
So it has come back through this side. Now the asymptote here is weak. Why am I saying it is weak? Because there is a region. The other turning point was what? We have 3, 0, and
0, 1.
okay.
And 0, 1. I think this one was supposed to pass
Yeah, I think
through
this one
1.
I've drawn it wrongly. Let me do it again. Okay, before I can draw that one, it's okay. Let us proceed with this one I was drawing. Now, when this one comes, because there is no evidence that it goes and meets the boundary down this way anymore, it will turn as a rectangular hyperbola here and go to infinity on my right. But that same line is supposed to bring back that what? That curve. Not so. But it brings it back on the opposite side. So it is bringing it back from down this way. Then here it is turning how? The turning point is what?
At negative
3, 0 and negative 3 and 3 over 4. Now, negative 3, I can assume it is here. So if it is here, 3 over 4 is where? There. So the curve comes and it turns minimally. When it turns minimally, does it have a y-intercept? Yes. What was its y-intercept? The y-intercept was, someone gave me 0, 1. So it is passing through exactly where the asymptote, which is horizontal, is. So it, after turning minimally, it comes, passes here, where the intercept is. Then it goes, as it goes to meet this wall, it meets another vertical asymptote, which takes it up. That asymptote takes it to heaven. Then it comes back through the ground, but on the opposite side. It goes and it turns again, maximally. It goes back with another asymptote, takes it to the ground. That same asymptote brings it back from the sky on this other side. Then it takes it back horizontally. It goes to the right and comes back. That is why we say the curve is continuous. There should be evidence that the curve has to go and come back. This is what explains what goes around comes around. The English saying that whatever you do, you might meet that curve at maximum and you treat it so bad, it will meet you here, where we have the rectangular hyperbola. And then it will show you fireworks. If you miss it here, you might meet it here when it is turning minimally. It will go and it will come back. That is how life is. It is continuous, just like this curve. We have a question. That is why I told you this number is very easy. But let us do this number as the last number. Don't rush this number as number 1. However much you like the curve, you enjoy the curve so much. You see the whole number, the whole paper, with the whole lesson, you have done one number. We have 36 minutes. I don't know that they're enough for the next one number I wanted us to do. Okay. So any other questions, guys? Tushime, you still have a question? I think most of the questions I've tried to answer them. Any other person with a question? Please, if you do, let me know and I answer your question if I can give you something else.
Teacher.
Yes, please.
Teacher.
Yep.
How do you know that it is a parabola?
How do you know that it's a rectangular hyperbola?
Yes.
It is because when there are two asymptotes meeting, one horizontal and another one vertical, then those two asymptotes are most likely to bring about a rectangular hyperbola if the curve cannot cross through. If the curve was able to cross through and there is evidence that it, like here, this is evidence that the curve passes through y is 1. We saw that. But if there is no evidence, you just sketch the rectangular hyperbola because this was x is equal to 9, for example. It was a vertical asymptote. This was y is equal to 1. It was a horizontal what? Asymptote. There was no evidence on this side here that the curve crosses the y is equal to 1. But this way there was evidence that it crosses it from here. Okay, so that's why it becomes a rectangular hyperbola. So a rectangular hyperbola is only possible if there are two asymptotes meeting, one horizontal and the other one is vertical. So it turns like a rectangular hyperbola.
Excuse me, sir.
Yes, please.
So I beg your pardon on how we find the asymptotes.
Using which method? Which asymptote? Even the horizontal you don't know, even the vertical you don't know.
Yes, teacher, I wasn't there in the previous lesson.
Ah, okay. Now, look at, I can't teach you any other method. Did you understand how I cross multiplied this?
Yes, teacher.
Design a quadratic in x squared by collecting x squared together and y and x alone together. And then this is your C in a quadratic equation. Do you agree?
Sir, pardon?
I collected yx squared with x squared to give me this part. Do you see that?
Yes.
I collected y minus 10x and 6x together. I got that. I collected this last coefficient without x. Now, to get the horizontal asymptote, after simplifying that quadratic, as clear as you see it here, get this coefficient on x squared and equate it to 0. This one gives you what we call the horizontal what? Asymptote. Is that okay? Even the notes you don't have them, you go to my YouTube channel and look for the notes. Because the first lesson I taught on the notes. Yeah? I think I taught on the notes, I think. Yeah, you go to my YouTube channel. Then, these are the horizontal asymptote, that's how you get it. Is that one understood? By equating this to 0, okay? Yes?
Yes, teacher, I've got you.
Now that is the horizontal what? Asymptote. The vertical ones, we equate the denominator to 0. That is why it is always good to present this by factorizing. When it is set like this, first factorize it back to that one. Then equate x minus 1 to 0 and x is equal to 9 to, okay, minus 9 is equal to 0. Then you get x is 9 and x is 1. These are what we call the vertical asymptotes. So the vertical asymptotes are always got by equating the denominator to 0. Is that okay?
Yes, teacher. Thank you.
Welcome. Okay. Guys, there is a question of UNAM which has y is equal to x plus 1 and x minus 9 over x minus 1 and x plus 9. I want that number. It is the last number of this category I want to do. Then we shall go for oblique curves. Even if I don't finish it today, I will finish it next week. No, you will finish it, I will guide. But I wanted that number so much. It's a very interesting number. You never said it one time. It was one which year? 198, 197, about 2000. But I remember it is a year in UNEP. Those of us with old UNEP question banks, anyone who can find it, I try to look for it, I can't find it. But if we can't, we are going to assume it is that one and we try that one out. Okay? Any other concern, guys?
Teacher.
I can proceed. Yes, please.
Teacher. It's number 14.
I said
Right.
number 14. Which number 14? What was it saying?
It's number 14, 1996.
Hey, it's number 14, 1996. Eh?
Yes.
What does it say?
Number 14. A curve is given by y is equal to x minus 1 into brackets x minus 9.
Thank you.
Divided by x plus 1 into brackets
the rest now
plus
I
x.
make like that. What is the first question? Show that y.
The first question.
Values between 1 and 1 over 9.
The first question. Determine the turning point of the curve.
Okay.
And determine the equation of the asymptotes of the curve. The next one, sketch the curve.
Then 2 says sketch the what? The curve. Thank you so
The
much.
curve.
That is why I want people who are steady. Now, guys, I'm going to take you through very fast. If I don't finish the number, I will need to see your curves. You'll inbox them to me. You will WhatsApp, you all inbox your curves on the group and we mark them from there. I will mark all of them from the group. But to start with, my friend who was asking me how to get the asymptotes, if you expand this one, you get x squared minus 10x plus 9 over x squared plus 10x plus 9. When you cross multiply, you get y into x squared plus 10x plus 9 is equal to x squared minus 10x plus 9. You'll get y minus 1 of x squared, yeah, a plus 10y plus 10 of x, a plus 9y minus 9 is equal to 0. The horizontal asymptote is y minus 1 is equal to 0. So it is that y is equal to 1. Then for real roots, now I told you it's better we investigate for non-real roots.
Excuse me, teacher. Is it automatic that y must be 1?
No.
Is it automatic?
No, it is not. There are some curves you'll find like this one, eh? Like y is equal to x minus 1 out of x squared minus 10x plus 9. You will see that this is yx squared, eh? Minus 10y minus 1 of x plus maybe what? 9y plus 1 is 0. Do you see that this one is y? So y is equal to 0 is the asymptote. So it is not automatic that it is always y minus 1. Eh? But only if the highest degree in the numerator is equal to the highest degree in the denominator, that is when they are always equal to 1. But also if the coefficient on the highest degree is not the same, then it also cannot be 1. It is only 1 if and only if the coefficient of the highest degree in the numerator and the denominator 1 is the same, and 2, both the numerator and the denominator have the highest degree as x squared. I hope I've answered you.
Yes, thank you.
Okay, so b squared will be 10y plus 10 squared is less than 4 times 9 into y minus 1 times y minus 1. You'll get 100 into y plus 1 squared plus 2y plus 1 is less than 36 into y squared minus 2y plus 1. Algebra, we shall get 64y squared. This is a negative 72. It crosses over. We shall get what? Negative 72. When it crosses over, it becomes a positive. Then this is 200 y plus 72y plus 100 minus 36 is less than 0. What do we get? 64y. I've never seen this answer I'm getting. Plus 272. Okay. My pen wants to stagger around. What is wrong with it? Plus 272. Plus 272y plus 64 is less than 0. Divide everything by what? By 8. Or by 4. What do you get?
That will be 8y squared plus 34y.
Plus 32, 34.
34.
Those answers, that's it again. Plus 8 is less than 0. When you simplify, what do you get? I've never seen these answers. I doubt them. Especially the 272. Let me first check here. This is 100 into y squared plus 2y plus 1, which is 200. Then this way we have y minus 1 times y minus 1 times 4, which is 36, of y squared minus 2y plus 1. 36 times. What do you get?
I'm getting 128y because this is a negative.
It must be 128
Minus
something.
2y. It's 128y.
Minus 2y is where?
No, this 100, 200y, 36 times this negative 2y is minus 72. So 200 minus 72.
It crosses over.
Because oh, okay.
You get it, eh?
Yeah.
272. I've done this number for the last like 10 or 15 years. If you include even my years of study, I've never seen 272. But okay, let's go on. Someone simplify this. What do you get? It is impossible. Because b squared is not greater than 4ac. 34 squared can't be greater than 64 times what? Times 4. 8 is greater. So it has real roots. Okay. Someone give me answers.
Negative 4.
Negative.
4.
You are right. You are right. You are very right. It is negative 4 and negative a quarter. Those are the answers. I know them. Because I've not reduced this to 2 to 17 to 2. Okay. Then we investigate our regions. If we recall how to investigate y less than negative 4. Negative 4 less than y less than negative a quarter. y beyond negative a quarter. If you are a good student who has been practicing so much, at this point, just know one thing. The answer is always the term in the middle. I'm not saying you cram, but because it is the only region you have where we can have 2 points. But there is one special curve which brings about the normal distribution curve. We shall investigate it one day. Okay, I'll do those funny curves next week, I think, before I introduce oblique. Whereby they just give you only one term. They give you 1 over x plus 1, x times 2. Sketch the curve. Those are some funny curves. If you don't know how to sketch very well, you might be in trouble. I'll also check on them next week. So let's start -4, you get a negative. You get a negative. You get a what? -3, -2, -3, no, -5, negative, -5, negative. You get a positive. Between -4 and -3, -2, positive, negative, negative, positive, positive, positive. So the region where the curve does not exist is -4 less than y less than negative a quarter. Remember, we saw that when we have this region, sometimes the region does not exist. Actually, if the curve has no turning points, also the region does not exist. But if it has turning points, maximum and minimum, it has the region where it will not pass somehow, sometime. So this is going to be a negative a quarter up, a -4 down. It will turn how? Minimally on negative a quarter. It will turn maximally on -4. So substitute back and find their corresponding values. I told you, use this equation here. You have simplified. Put -4. You'll get -5 x squared plus -30 x minus 45 is 0. You'll get x squared plus 3x minus plus 9 is 0. Do you see that x is equal to -3? Because this gives us x plus 3 what? This is not true. What do you get
So
here?
when you divide -30 by 5, you get 6.
6, now it confirms our answer. Okay?
Out of the value of x substituted. No, the value of y
The value of y?
that you substituted.
How do I know?
No, which value of y did you substitute?
I'm using -4 first.
Okay.
Okay, now can we put -a quarter? When you put -a quarter, we shall get a negative -5 over 4 plus -a quarter here. You get 10 times a -a quarter. You get a -2.5. So 10 minus 2.5, you get 7.5. Plus 9 of -a quarter minus 9. You get a -36, you get a -45 out of 4. When you multiply everything, so what value do you get there? Someone solve that quadratic very fast. Economics is closed. Yes, I'm solving as far as I can. Then you'll finalize. I'll need to see the curve you've sketched. Okay? So here I'm just hoping you get the region where the curve does not pass, the turning points, the nature, the intercepts. Those ones are obvious from primary. You will get them. Then the other region is to get all the x factors to 0, and you get the vertical asymptotes, and you also get the region where the curve does not exist. Then you will sketch.
X equals to 3.
X is equal to 3. Okay? Only like this.
I know.
And what?
Only that.
Okay, so this one occurs. The upper one is -3, -4. This is maximum. Then 3, -1/4. This one has confirmed what? Minimum. Anything else we have not found? Now I need I need also to show you this one. X is -1, X is -9, X is equal to 9, X is equal to 1. These are 4 columns, but these 4 columns result into 6 columns. I mean 4 critical points. Why? You have a region of X less than -9, -9 less than X less than -1, -1 less than X less than 1, 1 less than X less than 9, and X is beyond 9. Then we shall have here X -1, X plus 1, X plus 9, X minus 9. Then you'll have your sign of f of X. Less than negativity, 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 positivity. Between this, pick -5, negativity, negativity, positivity, negativity, negativity. Pick 0, negative, positive, positive, negative, and you get what? Positive. Pick 5, positive, 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 negativity, negativity. Beyond positivity, positivity, positivity. Okay. Intercepts. Okay, we still have some minutes. Intercepts when X is 0. What is Y? You go back to our equation. You'll have here -1, -9, 1, 9. The 9 vanish, you remain with a +1. Y is 1. So the intercept is 0, 1. When Y is 0, don't bother, come and substitute here. That is why this cross multiplication technique is very steady, very vital. It accumulates a lot of information. When you put there Y is 0, you will get X squared plus 10X. Or you equate the numerator to 0. Okay? When you equate the numerator to 0, you get X is 1 and X is 9. So we shall have X is 1 and X is 9. So X is 1, X is 9. You will get 1, 0, and 1, and 9 what? I so much wanted to sketch for you this curve, Naima. Okay. And it looks like this. Then it looks like that. It needs a new page. There you go. Let me try to do it very fast before Mr. Kawagambe says, hi, Mr. Hamza, please stop. We have here -1. We have here -9. We have here +1. We have here +9. Then this is the y-axis. This is the x-axis. X is equal to, which ones are the vertical asymptotes? The downer ones are negatives. So if the downer ones are negatives, so X is -1, X is equal to -9 at the vertical asymptotes. This is 0. We have Y is equal to 1 as a horizontal asymptote, which is here. I can draw it using blue. And if I draw it using a blue line, I'll be having something like this. Then you label it that this is Y is equal to 1. Now start shading. When you start shading before, you have a positive. This one has alternated very well. The curve is positive, you shade it down. Then here you shade up. Then between -9 and +1, here is 1, here is -9. I mean, this is -1, sorry. So this is -1. This is -9. This is 1, this is 9. Then between -1 and 1, here you shade what? Shade down. Here you shade up. Here you shade down. Where are our turning points? Our turning points we have seen. We have intercepts of 0, 1. 0, 1 is exactly here. We have 1, 0 and 1, 9. 1, 0 is here. We have 1, 0 and 9, 0. Okay. Then the turning points, there was a region where the curve never passed. That region is -1/4 and -1/4. This is where I wanted to show you this. And -1/4. In that part, the curve cannot pass there. So we shade it vigorously there. When the curve reaches there, it bounces. So the first turning point is where? The first turning point is at x is 3, -4. 3, -4 is minimum. 3, -4, -3 is here. -4 is here. It turns and it goes to this intercept down. When it turns maximally, follows this intercept down. This intercept brings it back from up this way. It comes and passes through the weak point of the asymptote, which is horizontal. It comes and passes through the intercept at the x-axis. It comes and turns minimally here, whereby at this region, this is +3 and this is -1/4, if you recall. Then it turns minimally and then passes through the intercept again. When it goes, it meets the horizontal asymptote and it goes to infinity, parallel to the asymptote. But that same asymptote will bring it back this way. My friend who was asking Ukasha, it has been brought back by this asymptote. It comes and meets another asymptote. It becomes a rectangular hyperbola. I'm lucky Mr. Kawagamba has signed in when we have finished the curve. Hence, the curve has passed everywhere. So please redo that number and redo that sketch and show me how you've resketched it very well. But remember, the curve is continuous. Okay, I'm finally lucky I've done the number in the fastest speed possible. I've never been that fast, but I've been fast today, really, for that number. Any point which you want me to screenshot?
Of Uganda, sir.
Yes, of Uganda. Thank you so much for playing a little. Just know the students we are also.
The previous page.
Okay, let me give you this previous page. This one is there. True. We are taking screenshots, sir, and with Amush.
The previous one, sir.
Okay, that one.
No, next.
Okay, there you go.
Okay, sir. Thank you.
You're welcome. Others who took the screenshots earlier, please help us share so that everyone can have the screenshots. Okay, guys, we meet next time. I'll post some of those other new curves I'll look at next week. Then you also try them out. Mr. Kawagambe, thank you so much for giving us those few minutes. Have a good day, everyone.